welcome to the application session of this year's Industrial Vision Days on Vision 2021. I am David Löh, Editor-in-Chief of the German magazine for Industrial Machine Vision and Optical Metrology. And I am pleased to introduce you Patrick Gailer. He's General Manager of Vision, and he's going to give a talk about 3D-Kameratechnologie, which supports automated, prefabricated house production. Mr. Gailer, stage is yours.
Yeah, thank you very much. Lunchtime, difficult time. Hope you try to get you to stay awake. Yeah, thanks that I'm for the invitation to be here. Very happy about that. My presentation will be about house fabrication, prefabricated houses. We have a 3D application there, but I will just give you a bit of picture where we are and why we do this. Vision is a small consulting and system integration company. We are 8 people, and our main focus is if a customer has an idea and it needs vision, we bring it to a solution. So in that case, we had a machine builder. They were already able to prefabricate some parts of a house, but the full idea was you design the house by a CID, an architect will do that, and you can fully automatic produce it, and they needed a 3D system from us. So in that case, this was the idea. We designed the systems, we developed the systems, we can do full systems, but we can also do part of them. And then basically we put it to maintenance. And the main feature is that we transfer the knowledge from our house to the customer. Ist da ein Slide wechseln? Zum Wechseln vom Slide? Ist das Ding, oder? So, like mentioned, we're 8 people doing vision since about 20 years. Do like agile development, whatever the customer is needing. I know that you should not say what you do not, but in that case, I don't know how to explain it differently. We do not off-the-shelf systems, so if something is already existing, that's not what we do. Usually people come to us with an idea where they didn't find something in the market, and then we develop that. So in this case, just to get an idea, we do 3D systems, and we do them if there's no solution on the market. We could use systems on the market if necessary, but if you need something special, then we design it. So we can do like very small ones up to the biggest one we did is 1 kilometer field of view. We have different accuracies, we have different speeds. The main idea is really to, for instance, to put a system on a crane, and you could measure instantly a 3D object, just to get an idea. So the prototyping usually is you define field of view, you define a resolution, you define the angles of view. For instance, in that case, at this example, 4 sides, 10 frames a second, not too high cost, €2,000. This is just an example of a system we have on a booth. If the system, the prototype is done and is satisfying, then we can also help to develop, in this case, for instance, a carbon system and make it ruggedized and stable. On the other side, you can define different software. If you need 2D processing and 3D processing simultaneously, or if you want to have a matching application, presence, fault detection. Just to try it, this is about the system which is behind what we did in the house, so I try to explain it a bit up front. So in this case, the house builder needed a very large system, and he wanted to do basically a bin picking application. I just give 2 other examples to give a bit the idea of how wide that works. So one customer has an industrial oven. It was a bit of weird field of view because it was very high, 2 meters high, and then like 600 by 800. They wanted to be very cost efficient, and they wanted also, so they wanted to put plates into an oven. They wanted to know the height, and then they wanted to know what is on the system. So we needed 2D as well. and used AI to do some recognition for that. And the other contrary would be a windmill application we have where we stop a windmill when a bird of prey is approaching. So it's also a 3D system which can have a field of view of 1,000 meters, 500 meters in depth. So we see a bird approaching from 500 meters. We have an AI which finds the bird, we track it, and if we do this on 2 cameras, then we can calculate the distance. So we have a 3D system there as well. But now to the main application I want to talk about today. Here was really the idea. The architect makes the design, so you already have everything in data, in digital, and now you could fabricate the house, ideally fully automated. At that point of time, we're talking about wood houses, so you have a frame. This was already been able to manufacture fully automated. But where they had problems is to put on the walls. So you can think of, you have every store of a house has about 3 meters in height, a bit more, because the ceiling comes in later. So you have large objects, and you need to pick them very, very precisely because you only have a gap of about 1 centimeter in between 2 walls. And if they are rotated a bit, they will not be placed next to each other, they will be placed above on each other, and that was a huge problem our customer was facing. The main problem he was facing is that the field of view was 3.20 meters large, 1.60 meters 20 height, in depth, and 1 meter height. So we have 4 cubic meters of field of view, and he needed to have an accuracy of 0.5 millimeters. So we really had internally an accuracy of 0.1 millimeter, which is for that huge field of view very demanding. Basically, the application, like I mentioned, is a pick and place. So we give the XYZ coordinates and as well the rotation angles to the robot so that the robot can pick the object and place it. Not only was the field of view quite demanding, the problem was also that these wall pieces which are delivered, they are not very accurate. They're even less accurate than what we had to measure. So they're a bit longer, a bit smaller, and still you have to find the right point where the robot has to grip it, because else the piece will fall off or it will not be able to place it on the perfect spot. The first idea what they had is that they place, because of the high resolution, the camera on the robot, but they had also a time problem. So they wanted really to have the next image whenever the robot placed the next object. So we needed to be finished with the full application after 8 seconds. The solution we offered is that we used 20 megapixel cameras. We arranged 8 of them in a stereo setup, calibrated them all to one big point cloud. And it was even possible to do that, and so we had different calibration methods so that the customer could recalibrate his system. And we also calibrated it for different temperature ranges, so it was temperature corrected. And that system is working now for half a year without any recalibration. The basic setup for the system is that what you see here is you have a pile of walls that can be up to 120 walls on that pile. That's not only always the full pieces, but it's also small pieces. They are layered in 70 layers, and we get, right before that pile is coming, we get the CAD data. We know we generate the models just in time. So we know for each layer which dedicated and really specific, customer-specific wall will come. We generate the specific model so that the robot then can pick up that specific wall part. And what I also mentioned is they they are prefabricated already from another company, and they are all placed by hand, so they are not stable, they are not completely straight, they are bent, they are not the same size, so you first need to have very accurate 3D data to know how the object is bent, and then to calculate the right center point for that. And obviously, on the other side, the robot, and this was not our doing, this is our customer's doing, the company Paul Köster, or in that case Bet. They are very skilled in the robot, so they had a robot system which were accurate throughout the whole area where it was moving, with 0.1 millimeters accuracy as well. So we could use it also for the calibration process. We could even prove whenever, at which point the robot had not that precision. Therefore, this is why we had different calibration methods, because main was the robot, but it didn't have the precision in all the places. You have to think that the wall parts are 3 meters long, so the robot have to have a distance of 7 meters. He's taking the piece on one side and putting in all over its head on the other side, so you have like 7 meters distance, and I think it was in the long length it's about 20 meters where you can move, and in all this area the accuracy was maintained. So in that way, this system, this application was able in that precision to pick off the wall, to place it. Afterwards, the robot put small nails into it, and the full walls were fully automated produced. So once the wall is ready, it is placed on a truck, and off it goes. So it's really the whole idea. You get the CAD data in, you generate the frame, you place your individual walls, you put the walls on the truck, off it goes, and the walls are then built on the site. And this is quite, there's still some people in there, but it's in my idea, it's a really cool story of having a fully automated productive house. The other possibilities which are on the market is like print in 3D and concrete, but I don't know, I love wood more, so I think it's a cool story. I was not allowed to put in the video here, so I invite you to have a view on the full video of the fabrication on the website from the company Bet. Like I said, that's our end customer. We provided the full vision system to them. So just to get an idea, this is one of our references we have. And yeah, if we can help anybody else on a difficult task in vision, we also like to do the easy stuff. We're happy to do that as well. But if the system is not existing, it's usually quite demanding, so this is what we get. So yeah, that is the story of the prefabricated houses and picking in 3D.
Perfect. Thank you, Mr. Gailer, for this interesting speech. We have no questions at the moment. If someone wants to know something, it's now the opportunity. Otherwise, as Mr. Gailer said, come to his booth and ask him directly. Okay, so
thank you very much.
Many thanks, Mr. Gailer.
Thank you very much.